Okay, I wanted to make a quick little video explaining how to make programs for a 3D printer. So it all starts out with an idea like this of the part that you want to 3D print. So to start with, you're going to need a program to create a 3D image or 3D surface. I use Autodesk Inventor. There's other software called SolidWorks, etc. So how it works is we start off with drawing a 2D image, and in this case I'm going to use text. So I'll base this on a job that I did for myself, which originally inspired me to buy the 3D printer. Let's make size 20 millimeters. So now this has just created a 2D image of text, and from there we finish the sketch and we can extrude it out, which will now create a three-dimensional image. So from there we've made our three-dimensional image, and in my case I joined the images with material so that it wouldn't fall apart, and as you can see from my old RX-7, when I got it resprayed all the badges broke, so I 3D printed my own badges for it, which saved me about $200. So once we've created our 3D image, what we need to do is save it into a format that's compatible with 3D printing software. So in all the cases I've come across, that would be a computer-aided design file format known as an STL, which is short for stereolithography. Basically just creates coordinates, or a file of coordinates that builds a 3D image. So we save it as an STL. So once we have our part file, the STL, we open up our 3D printing software, which I use Slicer. And what Slicer allows you to do is set all the machining or printing conditions for your 3D printer. And Slicer in particular has a lot of control over how the 3D printer functions, which is of high importance. So basically we'll print a tiny little line of plastic, and then every single layer from then on needs to basically weld into the previous layer. And so all these parameters are controlled by your layers, so it'll print a layer height of 0.3 of a mil. You can change your first layer height, your infill, so instead of producing a solid plastic part, you can create a honeycombed internal structure which is lightweight, saves material, and creates a fairly strong product. Speeds of 3D printing, how much of a override for extrusion width, which is basically how much material it pumps out of the extruder, are all controllable. And then so once you're happy with those, you create what's called a G-code file, which allows the machine to read a standard coordinate system instructions on where to go and how to go. So here's me producing the G-code file. See down there, it's a very simple program, so it didn't take very long to do. So now if we have a look at the file, so this is basically it. There's some information for the user about the types of conditions that are happening. Now if we come down here and look at one line of code, if you consider like a graph that has X and Y coordinates, then this is exactly how a CNC machine works, with the addition of the Z-axis, which is height. So basically G1 means it wants to feed to a certain coordinate, and your feed rate is governed here, which is basically 900 millimeters per minute. So let's say that this is a movement of 10 millimeters. It's basically saying move to that coordinate, and we want to pump out 0.39 millimeters of plastic through the extruder along that path at 900 millimeters per minute. So now when starting out 3D printing for the first time, or trying to get used to a new machine or whatever, I recommend just creating a very simple shape like a rectangle. So here we can put in our dimensions of 20 we can put in our dimensions of 20 millimeters in X and 20 millimeters in Y. So there's our 2D image. We'll finish the sketch. We'll extrude it out, say 10 millimeters is good. And now what we'll do is we'll create a shell. So we want the wall thickness to be, say, 2 millimeters. And there we go. This is a perfect little job to test the parameters of your machine, so that you can get everything spot on. So plastic melts into each other, you don't get any bowing, you can measure the sizes, and because it's so small, it's not going to take up a lot of time and material when things go wrong. So then it's just a matter of sending the G-code file over to your 3D printer and hitting the go button. So I hope my video helped you out a little bit, and I hope you enjoyed it. So feel free to like, subscribe, even donate if you wish. Thank you. Bye.